Welcome. In this video, we are going to derive the three equations of motion using the basic equations that we know. So the first equation that we're going to use is the equation for acceleration, which is A is equal to V minus U over T. So the first equation of motion is derived from this one, where I will just make V the subject. So V minus U times 1, we're going to have V minus U is equal to this times this, AT. And when this crosses the equal sign, we're going to have this V is equal to U plus AT. And this is the first equation of motion. Now, we know that velocity, so this is, in fact, we are using the concept of average velocity since we have two velocities, which is the final and initial. So this one, it is U plus V over 2. We're dividing by 2 because they're just 2. And here, what we're going to do is, the next thing is, we know that the velocity or speed is given by the distance, which is displacement over time. So this one, we can find that x is equal to vt. And this one, if we put v here, where there is v, we put the one for average velocity, we're going to have x is equal to u plus v over 2 times t. So this is the displacement, which is given by this. Now, from this same equation now, let us derive the second equation. So we know that x is equal to u plus v over 2 times t. So let us now derive the second equation from this. So we know that v is equal to u plus at. So if we put this into this, we're going to have x is equal to u plus at over 2 times t, which will give us u plus u. We're going to have 2u plus at over 2 then times t. So which will give us, when we distribute t throughout, what we're going to have is 2ut. So since we have 2 here, so divide by 2, we can even separate since this and this have a common denominator. So plus at times t, at squared over 2. So from this, we can see that this and this can cancel. And what we're going to have is x is equal to ut plus at squared over 2, which is simply ut plus half at squared. Therefore, x is equal to ut plus half at squared. So this is our second equation. Now let us derive the third equation. So we know that displacement is equal to u plus v over 2 times t. Now from this, we know from the equation of acceleration, which is a v minus u over t. So if we make t the subject from this, what we're going to have is v minus u is equal to at. So if we make t the subject, what we're going to have is t is equal to v minus u over a. So this is, let us call this asterisk 1. And so from this, we have x is equal to u plus v over 2 times t. So if we put this into this expression, into this, we're going to have u plus v over 2 times v minus u over a. So this one, if you simplify this, what we're going to have is x is equal to u times v, u minus u times negative u, we have negative u squared, then v times v plus v squared, then v times negative uv over 2 times a, we have 2a. So from this, we see that this will cancel with this. And what we're going to have is this x times 2. If we cross multiply here, we're going to have 2ax is equal to, then here we have negative u squared plus v squared, which is simply the same. If we take this on the other side of the equal sign, we're going to have 2ax plus u squared is equal to v squared, which can also be written as v squared is equal to u squared plus 2ax. And this is the third equation